share with you some preliminary results from the project I'm working on, and our approach towards adaptive agricultural processes enabled by open interfaces in data and services. So this approach we are developing within the national project, which has 4 partners. So the Telecommunication Research Center, where I'm working, and 3 partners from the agricultural sector. We have University of Natural Resources and Life Sciences, then the Research Center, the Sabina Research Center in Agriculture, and a company, which is providing very smart livestock localization systems and farm information management systems. And basically, because of our partner, industrial partner, we have a special focus on livestock management. So in this presentation, I will start with some words about the context, about the problems that motivate the work, about the related or existing work that we can build on, about the aims and approaches and goals, and some preliminary concepts regarding raw ontologies and semantic matchmaking in the system. And I will conclude the talk with some challenges and outlook. So regarding the context, basically our context is this intelligent agriculture or information-intensive agriculture or ICT-intensive agriculture. So these agricultural systems have a lot of, or integrate a lot of ICT equipment, advanced sensors, robotic platforms, localization systems, also applications for decision support, reporting, tracking, tracing. These agricultural systems can be a real showcase for the Internet of Things or Internet with Things. And because of this heterogeneity of the interfaces, systems, and data, we really need this true plug-and-play systems. So all these advanced systems come with some cost, and then it's this question why people invest. So what is the rational investment? Of course, this is cost saving, product quality improvement. Also, we can have very high precision of application. That's why the impact reduction, and we can achieve sustainability in using resources. So, in other words, there is a potential for process optimization. And as I already mentioned, because it's information intensive, there is also a showcase to demonstrate data to knowledge transformation, the smart data integration, knowledge management, and add data services. So when I was discussing what kind of a project we can I actually set up in this national call for projects with my colleagues from the University of Natural Resources, I was opting for some added services on these advanced systems, and they said, no, wait a minute, we have still some problems, unsolved problems, and we identified these 2 problems which then motivate our work. And the first problem is the problem of closed data interfaces, and the second problem is basically the problem of closed process implementations. And regarding closed data interfaces, if you think of a system in a stable with all these existing robots, they store data or produce data in proprietary formats. They confine data do not go out of these robots, so data are lost. There are a lot of manual handling, and also some data is used only for visual inspection, and that's why basically lost. But also we see that there are some very nice solutions where you have integration of several systems, several robots in stable, a milking robot, a feeding robot, and other robots. And these systems are mostly coming from a single vendor. They put all of the system together. But if you look at such kind of a process, you see first the process knowledge is not formally captured, so you don't really know how this process is modeled. then you cannot extend this process with some external data, and the context of the process cannot be extended. We cannot put the two processes together, so the processes cannot be dynamically changed. So that's why we say, okay, we can actually try to have a contribution exactly here on these open interfaces and open process models, and be very practical, offer methodology and tools for automated creation of new processes or plug-and-play process infrastructure. And our approach is intensive use of semantic and service technology to achieve interoperability, accessibility, and configuration. The process for us is a dynamic composition of semantic services. And we also distinguish between this monitoring and optimization of running processes, but on the one hand, and on the other hand, making recommendations about what can be done in the system regarding system update, which can then support more optimal processes. So the optimality of process is deeply embedded in the concept that we are developing. And the goal, as I mentioned, we want to be very practical, so to provide open source API that can be a plug-in solution to plug in all different devices into such a platform for adaptive process optimization. Of course, there is the good thing for us is there is a lot of work already being done, and this is the work that we are building on. This work is also work in progress, so the new results are coming each month. So in the domain of the interface data models, we see the existence of some standards. Some are very well established, like ISO-BUS. The other that we would need more in our use case, ISO-AGRINET, is not so well established, and also it is related with a very tedious process of implementation and integration. Then there are standards that go into defining the XML representation of the data model for interconnection of machines and personal computers, the smart computer, or on the other side, integrating the farm computer with the external systems. And as I mentioned, the results in this area are also coming each month, and recently, very recently, the project iGreen published also this agro-RDF data or representation of the agro-XML data model in RDF format. However, this is still not adapted for, or they're not information needed for livestock farming. On the other hand, we have this ontologies, immense work already done and driven by Food and Agriculture Organization, and the AgroVoc vocabulary, which is a control vocabulary with many different terms covering this huge agricultural segment, which is now also being published as linked open data and used for labeling or annotation of Agri's big database, which is then also published as open data. So there are also other thesaurus and ontologies that we're looking at and trying to understand what kind of this ontology or data models can be adopted and integrate in our ontological, in our ontology. And this, all these vocabularies and basically data requests are quite static, so to say. And we want to have something dynamic, and basically here we can build on this idea of semantic web services, composition frameworks. Here we also have a lot of recommendations, existing technologies. The semantic web service combines the web service plus the semantic annotation, which can be in OWL, or we can use the annotation for the FISTL. There is also a recommendation or proposal for a web service modeling language and web service modeling ontology. This framework is extensively used in e-commerce or traveling segment. But if we move in the REST world, we need much simpler solutions. Here there is Micro, Vismo, Light, and many interesting new frameworks based on REST, like SWAP and SADI framework, which we use as kind of a input for our framework, inspiration for our framework. So just to see a little bit of the dynamics that we want to cover with our architecture. As I mentioned, we are targeting the application developers, so we want to develop tools for application developers and service developers. This is basically the toolbox or the running system which has a semantic repository and the running execution platform. The services are dynamic, they emerge with the platforms, they can register, be invoked. In the system we have the process monitoring and application, as I mentioned, this recommendation part. So let's just look a little bit more into the activities and system functions, so activities, creation of the domain model. So we will provide the starting the domain model, so to say, but the application developers are those who will evolve this model. So the model should be flexible and be evolvable. Also, this model is the basis for the creation of semantic service specifications. Then the other activities, design and deployment of semantic services, or design and deployment of processes, which are a combination of services. And then in the system we have two functions, process monitoring and annotation, and this creation of recommendations. So just simply here, how the services come into the system, they come with the devices. So you can imagine you are the vendor of a new product, and basically a service developer can use the plugin software to create a plugin which can wrap this the functionality of this product and make it available for this platform. But still, when you have the implementation, you have the service specification, which is then published in the repository, you still don't have this service in the system. So first, a farmer has to buy this equipment, part of equipment, and then basically this service can also register and be available in the system. On the other hand, we know that this service is available, so we have this service specification, and if we look then in the service composition, the application service developer should be able to use the system to create the process descriptions based on service implementations, but also service specification. And this is basically the basis for all our also recommendations. That means that on the one hand, we can set up a process which uses all implemented services, and we have to have some notion of the optimality of this process. But we can also set up the process of service specifications, which means that these services could be possible, and the recommendation can be given to the farmer that if he can adopt or update his service system with his services, his process could be made more optimal. So in service operation, when you have this running process, then the service is registered, they are invoked, and the process is monitored and can be adopted. And as I mentioned, is in recommendation, we have the possibility to always also work, or the idea is to be always able to work with service specifications in order to find out what are the more optimal processes and give this as a recommendation to users. So as I mentioned, this is the preliminary work, or we have started in summer this year and developed a lot of stuff. We're very practical. This is you cannot see from this high-level architecture, but basically we're also deeply in some implementation. But we are also doing now trying to understand this all the requirements for the domain model, for the ontology, and how much or what can be reused from the existing vocabularies, ontologies, and also be very careful with this is support for semantic service specification and also optimality notion of processes. And currently we're working on this plugin API development, following a little bit of a thinking approach and working also on the implementation of the service execution environment. So the next steps are more focusing on workflow modeling and this matchmaking components based on SparkQL, and then looking at the monitoring framework and recommendation framework. So that's it. Thank you very much for your attention.
Are there any questions?
So, I didn't understand if you are going to realize your own service execution environment, or if you are going to use an existing one like Taverna.
We're evaluating also the possibility to use Taverna. However, we have a little bit different use case because Taverna Taverna can be used for many different services, but now it's mostly used for services that work on data. So we have data set, put your data set from one service to second service to change the services. And here we also need a little bit more of support for services that are dealing with this equipment and the data that is coming in runtime from the equipment. So here we look at what is the dynamic of the data and are we processing the data once it becomes stored as data in a database, or we also look at very equipment near services.
So is it the case that you examine custom-made solutions?
For example, yes,
maybe you decide to develop by yourself some parts.
for example, we are looking at really to go into the direction of SAD. SAD is used, we can use services in Taverna. So Taverna is also about workflow management. If Taverna can satisfy our use case, then this is what we try to understand now. Then we can also use Taverna. So because we also want to just add to this open source framework of tools. And but in a practical sense, we will have 3 experimental farms, and we will have we will develop these plugins for several different types of equipment, and also have to demonstrate them that we can set up these dynamic processes and work on such a domain model, have ontological description services.
Any other question?
I have a curiosity more than anything. So from the developer point of view, this is actually great, right? Because you can make different tools to interpret and to have a workflow, let's say, some integrated workflow. But as you were saying in your presentation, so normally this is done already only in a single vendor framework, let's say.
Yes.
Now, why would vendors want to open up their APIs, since if they are locked, they could also sell to you other products that they have? So how can you convince them to open this?
Well, the market is not only, the market is being dominated by these big vendors, but there are a lot of newcomers, so to say, and they are maybe specialized in one particular robot. That means they don't want to go into some other robots. They are interested in making this interoperable. So the question or the assumption is actually that it can also stimulate this sector, because if I can add my piece of equipment to the other piece of equipment, I don't have to be that big, or the farmers can also maybe then combine the equipment of different vendors. So this is the use case that we are also looking at in the project, where we have the provider of one solution, for example, this tracking solution, then the provider of the feeding product, which is just feeding product, and then also taking some information which is related to the milking product with the other menu and demonstrating this kind of chain.
Okay, thank you very much.
Thank you.
So, I'm going to the next presentation. Professor Deborah Montali, she's not going to be here today, so I will try at least to present her work. Just a second. Deborah Montali is an associate professor at the Documentation Research and Training Center of the Indian Statistical Institute. To begin with, a small introduction. First, the paper is about the issues in harvesting resources from agricultural repositories. An introduction is about the harvesters facilitate the aggregating the data from different repositories or resources like journals. Aiming to enable centralized access to even full text and dialogue. While harvesting is fairly simple and straightforward, it is not without some challenges. The aim of this paper is to discuss some issues regarding harvesting, to present and compare two services, Demeter and Indus Aggregator, that harvest the agricultural condition data, and present very briefly the fair-based model intended for thematic harvesting of data from generic repositories. The issues that we have discussed in this work are combined based on the experience of implementing and using two services. One is the Indus Aggregator, that is a DSpace-based harvester that covers many repositories in Asia actually. And then the second one is Demeter, DKP harvester that is covering 22 data providers. So Asia, there are almost 50 Asian countries, from which 26 have digital repositories, global and local. Around 1/3 of them have exclusive agricultural domain-specific repositories. Most of them they are available. They have OIP-based targets to make use of the agricultural journals. Indus covers both repositories and OI-based journals. Presently, about 10 countries, metadata from 10 countries have been harvested, 57 journals on agriculture, 8 digital repositories. These are the statistics. So this is the interface of Indus Aggregator. You can see that it's a DSpace repository. There is a list of repositories and journals that you can browse. So the challenges regarding Indus Aggregator, as we know that many repositories they don't have available OIP-based targets. This is one issue. Another issue is that the persistent identifiers that they are not working properly, especially in DSpace-based repositories. Another issue is multi-linguality. And last one is how to filter agricultural resources from generic repositories. The repositories that we have harvesting Indus Aggregators are coming from OpenDoar. Regarding the organization, Indus has the possibility to of a hierarchical organization. Instead of it has a flat linear organization arrangement based on traffic patterns. But browsing in Indus Educator, you can browse by author type subject. Instead on the editor, you can just go browse through the list of data providers on a chronological order. Regarding research, field-level search is possible in Indus. In addition, search features such as proximity research, fuzzy search, and custom terms is possible. Instead, in the middle, simple and fast level search by different elements. Indus Educator gives the prototype of the Isaac Gates and Atom, while Demeter no. The same for OS support and email alerts. Some issues that have been identified in harvesting regard linking. Linking mechanism implies the record is based on URIs. Here the standard URI itself comes into focus. However, many repositories have not implemented standard URIs. So this is an issue. For example, a significant number of repositories that use this page do not register within C and I, and simply use the default format like that, but leads is actually broken. So in such cases, only the metadata can be seen since the URI is not you cannot link. Another difficulty is to trace the base URLs of repositories unless they have been registered with one of the directory services such as OpenDoor or Premier. If base URL is not provided, we left to guess based upon whether the data provider is using something like this base or eQueens and what would be the base URLs. Some issues regarding metadata, the poor quality metadata. Many authors support resources that they are not compliant to specific standard, or they provide a minimum set of metadata. Another issue regarding quality is that they don't follow a standard vocabulary of someone. And then identifying what's target deployed, in identifying inqualified dubbing code, there is a way to specify for vocabulary used, what is the vocabulary being used. On the other hand, in plain dubbing code, things are more fluid, so it becomes difficult to associate the terminology with the standard. Harvest is a model for harvesting automatically from generic repository. At present, the system is a test bed and successfully tried to harvest resources and data related to agriculture from 3 generic repositories. This is the workflow, so we have the data collection in the first place, which is being indexed Solr indexer. The indexing is based on some agricultural terms based on Bible, keyboard, master, and these we're going to see in details later. They are trying to do once with the agricode. In order then the records will be selected and they're going to be harvested and available for the end user. So harvesting by domain. The proposed is a model for identifying agricultural-related resources from generic repositories and reharvesting selectively to provide access to such aggregated collections in agriculture. The first step is data collection. Sets from generic repositories such as open access university repositories, resources from harvested self-using directories such as DOATS, OpenDoor, and Open Archives to source data providers. They should be OIP compliant, or belongs to agricultural domain or not. We adapt an agricop lookup tool. And finally, the thing harvester harvest then collects and organizes this into windows. Thus, the RICO organs, which match the agricultural terminology, are interested into the harvester. An interface that enables search and browsing by title, often date or subject, is presented to the end users. Some conclusions for future work. It is intended to run evaluation for performance and also for comparing the SASIX rate of the procedure of using agricop-based lookup tool for identifying agricultural-related resources versus manual checks as adopted by other systems. And the experience with building targets brought forth several issues